Hello again, grade 12s. In this question, we are going to apply our double angle formula and our reduction formula. In simplifying the expression, I leave the 2 sine squared x as it is. I then examine the tan 360 degrees minus x. What quadrant is that expression in? That is in the fourth quadrant. If it's in the fourth quadrant, then I know that I can reduce that to negative tan x. The sine 2x can then be rewritten as 2 sine x cos x. Looking at my denominator, I see that I have 90 degrees minus x. Now that is an example of a complementary angle. Now with complementary angles, I know I can then rewrite that as x. Right. Let us now see what we can do to make our lives easier. I have a negative and a negative that then becomes positive. Right? Tan x can be rewritten as sine x over cos x because that is a fundamental identity. The 2 sine x cos x I leave like that. And in your denominator, you still have your sine squared x. Right. Now, is there anything, that I can cancel out or that's common in the numerator? Yes. Cos x in this denominator can cancel out with that cos x there. Right. Now, I am left with 2 sine squared x plus sine x times 2 sine x, that becomes 2 sine squared x. I still have my sine squared x in the denominator. Now, do I have like terms in my numerator? Yes, I do. Those two terms then simplify to 4 sine squared x divided by your sine squared x. Sine squared x divided by sine squared x, that cancels out and I am just left with 4. The next part of the question asks us to determine the values of x where x is between 0 and 180 for which this expression is undefined. This expression is undefined when cos squared 90 degrees minus x is equal to 0. So that's the first thing you need to indicate. It's undefined when cos squared 90 degrees minus x is equal to 0. Now you'll recall that we changed that, using complementary angles to sine squared x being equal to 0. Now sine squared x is basically sine x multiplied by sine x. This is the same trig ratio, so all you have to do is now determine the general solution where sine x is equal to 0. Okay. In the next step in determining our general solutions, you then have inverse sine 0 plus 360k, where k is an integer. This is the first general solution. The second general solution is x is equal to 180 degrees minus inverse sine 0 plus 360 degrees k. Again, where k is an integer. All right. Now I need to solve this. The first expression will then become 0 plus 360 degrees k. Okay, the second one is x equals 180 degrees minus 0 plus 360 degrees k. Now your question specifically asked for us to work out the x values between 0 and 180. So what I will then have to do is I'm going to try k is equal to 0. Sub in k equals 0 into your first equation and the second equation for us to find the actual values of x here. So for the first one, when k is equal to 0, I see that x is actually equal to 0. For the second one, subbing in k is equal to 0, the x value that I get is 180. So those are the two values that I get, and they are within this range here.